Hello everyone, this is Jeff Eckstein from Festo. In today's video, I'm going to show you how to integrate Festo's newly designed CMMT servo faceplate for an Allen Bradley PanelView Plus 10-inch HMI. Today we're going to go over where to get the files and how to integrate them into your existing HMI project and PLC project. We'll start off here with a brief introduction by looking at this PDF. So you can get an idea of what we're talking about here. This is a Allen Bradley PanelView Plus 10-inch HMI with our faceplate. A couple of notes on the side here. And on the second page here, you can see the AOI that goes in your FactoryTalk Logix program. And it is designed to be paired with an existing Festo point-to-point AOI, which can be found on Festo's website. We are assuming that you already have a working drive and program in your Rockwell PLC. Once you have all that stuff done, this faceplate AOI can be added with ease. So in today's video, we're going to be working with some hardware. Starting from the left side of the view here, we have our single phase 120 volt input, 24 volt output power supply. And next to that, we have a Compact Logix L16ER processor. And then beside that, on the right, we have our CMMT-ST stepper drive. And then the software we'll be working with today is FactoryTalk View Studio version 13 and Studio 5000 Logic Designer. I'm in version 35. So let's go ahead and get started. In the description of this video, you'll find a link that will take you to a public GitHub repository where you can download the necessary files for today's integration. Once you click that link, it's going to take you to a screen that looks very similar to this, and you'll see a little download icon to the right side here. So we're going to go ahead and download the necessary files. Once we have those downloaded and you open that folder up, you'll see a couple other folders in here, a couple subfolders. Let me sort this. We have a little bit of documentation, the raw AOI that goes in your Studio 5000 project. Then we have sample PLC code for versions 32 through 35. And we also have the HMI project via an archive file and a runtime file. So we're going to go ahead and get started here. I'm first going to get this archive file into my FactoryTalk database. And I'll do that by double-clicking the file and then following the prompts. And obviously I already have this file in my system, so I'm going to have to overwrite it. Okay, it looks like that's complete. So I'm going to go back up one folder and go into my PLC project. I'm going to go ahead and open up version 35. That's the latest version that I have. Okay, once that opens up, we'll go ahead and launch FactoryTalk View Studio here, and we'll open up the project that we just got from our download, and that's the Festo CMMT faceplate. Go ahead and open up that project. Okay, let's go ahead and get started here. This is the file that I downloaded from the link, and I'm going to go ahead and just expand the Displays tab and open up the only display that's in here. And this is the faceplate with all the objects, images, displays, all that stuff. I also want to open up the local messages and just be aware that these three messages, along with this screen, are going to be the items we have to get out of this project over to our existing project. So I'm going to go ahead and minimize this and pull up my existing project. And this is just a brand new project. There's nothing in here. I just created a brand new project. I did set up some communications so that I can do a simulation here in a moment and show you guys the faceplate working. So the best way to do this, you can drag and drop this screen into your existing project, which for all intents and purposes will copy that screen to your project. The problem I found with doing this is when you open this project, everything's in here with the exception of these PNG files for these images here. For whatever reason, it doesn't come over when you drag and drop like that. So the preferred method, I'm going to go ahead and remove this. The preferred method would be to just grab these objects and copy and paste them. So that's what I'm going to do. Just going to select all my objects here. And that happens from time to time. All right, copy those. And then over in my existing project, I'm just going to create a new display. And I'm going to paste all my objects in here. Now, it did miss that text up there with my copy, so I'm just going to come back over and grab that text real quick. And I'm just doing Control-C, Control-V. All right, so now all my objects are in there, and you can see it brought over my images too. So that's a much cleaner way to do it. Like I said before, the next items we're going to need are these local messages. These can be just click and drag into the project, and that works just fine. So we're going to do these one at a time and get all three of those lists in there. All right, that should work. And at this point, we're done with the project that we downloaded, and we could just stick with the project, the existing project that we're creating. So a couple quick things to note here. You can kind of see the faceplate here and the general design of it. What I want to show you is the local message over here named access names. If you open this up, you have 10 names in here available. Those names are what's going to be displayed in this local message display. As I scroll through my drives, when this faceplate is implemented on a piece of hardware or when you're simulating, and I scroll through previous and next to all my drives, that name will update, and then the corresponding statuses and messages will display for that drive. So just come in here and name these whatever you want to name them. For example, we can name this one product pusher. Maybe we have another axis called turning screw, so on and so forth. So just name those what you like. And that's really about all you have to do in here. So we're going to jump over to the PLC program. This is the program that we downloaded via the link, and it just contains one rung with your AOI. So you could just export this AOI and import it into your program and then create these tags on your own. The problem with that is this output tag needs to be a controller tag, and it needs to have this exact name. Otherwise, it won't be linked to the faceplate. So the best way to do this is just export this rung. I'm just going to throw this on my desktop. You see I already have it in here. So I'm going to export and replace the file that's on my desktop. That's really all we need out of this project. So I'm going to minimize that and open up my existing project. And you'll see in here I do have a functioning Festo servo drive with the point-to-point AOI on my workbench here. So I'm just going to go ahead and import that rung that we just exported, bring that into my project. So when you do the import-export function, it obviously, most of you know this, I'm sure, but it creates the tags for you, creates any AOIs and any UDTs that may be needed for the AOI. Now this AOI has been in this project before, so it sees that it already has these UDTs, so it's just going to use existing. But this way you don't have to worry about whether it's a local tag or a global tag. Whatever was on that previous rung that we exported, that's how it's going to define these tags when you import it. And that's the preferred method. That'll make this a very seamless integration here. So I'm going to go ahead and import this rung as pending. And you'll see the AOI here. And it is just filled up with spare access tags. And from here, you just need to load up your point-to-point Festo AOI tags, which will be this tag right here. And you can do that by copy and paste, click and drag, or you can search for the tag. I do have an additional tag in here, even though the AOI is not in here, so I'll just go ahead and put that one in slot 2 there. So you just load this up with your axes. If you have more than 10 axes, you can modify this AOI if you'd like. Just open the AOI, and you can take a look at how it's designed, and it'd be fairly easy to expand to 20 drives, 50 drives, whatever you need. But it's currently just set up for 10. I'm going to go ahead and accept these pending edits, and then I do want to show you guys one other thing. So on the AOI, or sorry, on the faceplate, when you hit the next and previous button, if you only have 2 drives, maybe 3 drives, even 5 drives, it seems a little wasteful to allow the operator to click this and scroll through a bunch of spare drives. So what we prefer to do is know how many drives we have, and then when you hit the next button, once you get to the max number of drives, stop allowing any more switching of data. So we can do that in the AOI by simply monitoring this tag for the AOI. Expand that out, and you'll see the last element here of this tag is the total number of drives. So you just want to set this to whatever your total number of drives is. I only have 2, so I'm going to make sure I set that to 2. And then what that'll do, again, when I hit the next, it'll go from 1 to 2, and I hit the next again, it'll stay at 2 until I hit the previous button, so on and so forth. It reduces some confusion for the operator that's going to be interfacing with this faceplate at the end of the day. So I believe that's everything we need here. I'm going to go ahead and pop over to my HMI, and I've already set up my communications with my PLC, so I should be able to just hit this play button, and we can simulate this display. And it looks like it's working. So right now, it looks like I'm telling the drive to be enabled, and the drive's saying it is enabled. So I'm going to just verify that over in my PLC project. And it looks like I am telling it to be enabled, and it is enabled. So I'm just going to go ahead and disable that drive. We'll pop back over, and we can see that I turned the enable off, and the drive is disabled now. And there's a multitude of signals in here that'll help for any troubleshooting purposes at the end user. Now, one thing I do want to do, I'm going to go ahead and enable the drive, and then go back to our faceplate. I'm going to slide over here on my workbench and just unplug the encoder cable out of my servo drive. And you can see when I did that, we got a fault message. And these fault messages are laid out exactly how you see them in the manual, which you can get from Festo's website by looking up either of these drives. But the fault message is laid out like such. The main category, encoder, and then the subcategory, quadrature, incremental encoder. And then this third category is the actual description of the fault. So incremental encoder analysis invalid. And the remedy for this is check encoder cable and restart the device. So that's extremely helpful. There's a slew of alarms that can come out of this drive, and it's very helpful to be able to see them right on your HMI and not have to get any other kind of software out or laptop or anything like that. So this is a huge benefit. I went ahead and just plugged that cable back in. So I'm going to disable my drive and then acknowledge that error, and then re-enable my drive. And because I unplugged the encoder, it's going to do a little commutation there real quick. And let's go back over to our faceplate, and we can see our fault's gone, our access is enabled. We are all good to go. So that should about do it for this video. I appreciate you watching, and take care.